Hello everyone, welcome to the class of CN3121 Process Dynamics and Control in this new semester. I am your lecturer for Part 1. I'm an assistant professor in our department, Chemical and Biomolecular Engineering. You can call me Dr. Wang or Dr. Xiaonan. From the Part 1, we are starting with process dynamics. Then we move to the second part of this module, which will be process control, further taught by another professor, Qiumin Sen, in our department. So here is my contact information as well as 3 TAs. You can feel free to contact us for any questions related to the module or schedule consulting time. During this special time, we have switched all the learning online, but we hope to provide you the full experience of learning and interaction. So feel free to schedule the small group consulting or face-to-face meeting, even by email. So today will just be a quick introduction of myself and this module. I want to start to bring you to my defined area called Smart Systems Engineering. This is not equivalent to what the module you're learning in ChemEng, but this is what we do in the academic and industry research. I briefly show it here because the content we learn in this module is very closely related to what we do in research and the industry career. We are developing this multi-scale smart system engineering, focusing on different time scale from very fast second to daily operation to yearly planning. We are focusing on different scale for the spatial resolution, like the nanomaterials, the process level, the plant, until the city level, smart city, global level, and climate change research. Why do I need to show this to you here? Because when we study the process dynamics and control, we target to tackle the problem from this part, from the multi-phase system process units to plants. We are learning how we can use the computing techniques to realize the smart and intelligent operation in future. Because nowadays we face this transition towards the fully automation, especially during this COVID-19 situation. We realize that human beings cannot be hands-on in a lot of stuff. We do rely on the process automation and machine intelligence to support us. Therefore, we can always tackle this smart nation, smart city goal by investigating energy, materials, healthcare together to form the future smart systems. So this smart is enabled by what we will learn in this module as well, the process modeling, dynamics, control, and the fully automation for Industry 4.0 practice. So broadly speaking, this module will cover a lot of essential parts in future industry and life. Then if we come back to focus on this course, we will start with dynamics in part 1 for the first 6 weeks plus a 7th week Monday lecture, and then we move to part 2, process control. There are some pre-requirements of topics you may have learned in your first 2 years in engineering education. First of all is the conservation principles, which you learn in heat and mass transfer balance. So you should be familiar with developing these simple models for unit operation and write unsteady state method energy conservation statements. Right. So if you have not practiced this recently, no worries. We will start to introduce the basic concepts and the two skills again. Well, applied mathematics is also very important. This module is very heavily relying on mathematics operation. So previous students sometimes complain they're too complex math and abstract concept. If you can follow us carefully along the journey, we will enjoy the beauty of mathematics. Hopefully, it's not that difficult. We just use several specific techniques in mathematics, such as linearization. How do we linearize a nonlinear ordinary differential equation using Taylor series, truncated Taylor series. We will get you again how these concepts are, but hopefully you have learned that in your math module before. And especially we will apply regression techniques to fit data and extract model parameters. This is very important, as regression is a very strong tool for us to utilize the build power find the hidden rules of data. So we will use this in our project as well to fit the Planck model to get the data-driven models. And finally, we will employ unit conversions to maintain unit self-consistency in calculation. This is very helpful in exams. When you do the mass and energy conservation, you should check your calculation by checking if the units on both sides of the equations are consistent. So these are something you learned before, and keep in mind to reuse that. And here for computer usage, this module also requires the students to be familiar with MATLAB, and then we will further use Simulink for system simulation, because every year the module is set a bit differently. I believe for this year most students have the very basic fundamentals of MATLAB in your previous course. Right, I will do a quick survey. If still a majority of students do not know how to operate in MATLAB environment, I will give you a more detailed tutorial. If you have already used that, then I will just upload several tutorials for you to get familiar with it again. Well, Simulink is a new component here. It's within the MATLAB as kind of a toolbox. You can use this for the process control related topics. We will introduce how to use that later through hands-on sessions as well. For the course structure, because we're using e-learning for this big class, we have 190 students here. We will use a combined e-learning lectures with Zoom sessions. So like this lecture, I will try to upload this to capture the content so you can download or learn anywhere, anytime. Well, I also call some Zoom sessions during the lecture time if you prefer some online real-time learning experience, more face-to-face discussion. So this is for the lectures. For tutorials, similarly, I will upload the lectures video. Well, for the lecture time, during the tutorials time, I will be there in the Zoom room to be able to answer your questions. Or you can also schedule the consultation hours by appointment through my email. We also have a discussion forum here on LumiNUS where you can upload any questions or discuss with your peers or myself or TAs for any course-related questions. I also put a survey there on LumiNUS because I want to really learn your background and your preferred way of learning. Like, do you prefer offline learning lectures or you prefer these interactive sessions? I will send the link to you later. So please help to finish this survey so we can try our best to improve and satisfy your needs. Okay, and the learning outcome for this module, right? So now it's a bit earlier to discuss this, but I listed here. After we study the first part, we can come back to review those key questions. This is also the list we hope to grasp and test in the final exam. So first of all, we need to get to the dynamic model through linearization and use the transfer function model, which is convenient for further analysis, controller design. So linearization is a technique, very important. Transfer function model is what we will teach you as a new concept. Secondly, we are studying the dynamic behaviors of complex process based on the time domain and transfer function representation. So time domain is what we are familiar with based on the time-dependent behaviors, while transfer function is another way to switch to a new domain called frequency domain. So this will be something totally new to you. So this is key message we need to learn in this module. How do we describe the dynamics in the frequency domain and obtain empirical models using step response and regression methods. Furthermore, we will analyze stability and performance of feedback control systems. This is a part 2 topics. And also we learn a series of commonly used controllers. Later on you'll see PID controllers, using tuning rules, model-based design methods, and frequency response methods. Finally, in the project, we will implement these control strategies and use computer-based tools to study the process dynamics and the feedback control system. Right, so this is the overall learning outcome. They seem complex, but when you finish a module, this is the outcomes you will be able to use in your future practice. Here is a textbook and the reference. We have the essential text at this book, Process Dynamics and Control, which is a classic textbook in the field. Luckily, the soft copy of this is available, so we also have a spare copy on LumiNUS files. You can also download it from our library. So this will be the basis for learning. If you prefer hard copies, I believe you can purchase this both the third and first copy. These are the hard copies available in the library. This is a first copy corresponding to the PDF file. Previously, many students purchased this economic version. It's the same content, but just with a soft cover. If you like, you can buy either version. Just the order of questions is a bit different. Please note for ease of reference, in our lecture notes, we just follow this first edition e-copy about all the equations, chapters, because two chapters are slightly different. This latest version added some content, so we will refer to this latest version. And there are many good references in the field, like this recently released textbook. You can also borrow or purchase it to read if you like to get more information about process control, simulation, or other relevant technologies. Nowadays, we have many excellent e-learning resources, especially during the lockdown period. You can easily search on YouTube or Google. We also have our lecture videos on YouTube. You can search for it. So learning freely, feel free to use those resources. Moreover, we have your course grading, which is the part everyone cares. So this is pending the final decision, because when involved with the e-learning, many uncertain parts may come. We may massage this percentage a bit, but overall we are sticking to this. Continuous assessment accounts for 40% of the whole evaluation, which consists of 2 projects of equal weights, each 20% of the total mark. Right, so for part 1 and part 2, we have each project assigned weights. So for this part 1, process dynamics I'm teaching, you will get a group project statement in late August or early September to start working as a group. Later on, I will show you the group assignment. And for the final exams, we normally use this as a paper-based exam. Now, since we cannot meet together, so we may use some online examination. But the final questions will be divided to 50 marks for each part in the final exam. So remember to review the content when you prepare for your exam. I will also give you some homework questions for each week, each chapter. This will be assigned for learning, and we can go through their solutions either in lecture or in the tutorials, but those will not be marked. You don't need to submit it, just for your own learning purpose. Okay. One important thing, the top student in this module will win a book prize. So that's an additional prize that will be mentioned at the commencement ceremony. Good luck to your learning to win this final prize. Okay, with respect to a project, it's a very fun and informative part. From past years' students' feedback, they do feel this project is very helpful for them to practice the concept and also interpersonal skills. Okay, so we will have this team project. We will form groups. Each group should have 5 students. If you cannot find 5, 4 students are fine as well. And each individual team will submit 1 written report before the due time. So you may choose your own team members. Note here is only 1 teaming for both projects. And each group will name a coordinator. You can choose your own team number as well on first come first serve basis. I relay the grouping on LumiNUS. You should be able to find your team members before the 31st of August. Sorry, should be 2020. Now it's 2020 already, right? If you cannot find your team members properly, I will assign you just after the deadline. Okay, so further details will be posted later. As I said, homework assignments are just for practicing your problem-solving skills. These are a bit more difficult than the final exam questions because homework you may have more freedom to look for different resources and spend time on it. We will provide the answer sheets without marking. And for final exam, it's normally open book, open lecture notes, but you cannot go to search for online resources. We will announce further details later. Okay, now we can have a detailed look at this part 1. I will introduce you to the fundamental principles in process dynamics. When we finish this part, we should be able to know the terminologies used in chemical process dynamics and control, and simplify a first principle dynamic model. Right? First principle means normally built based on the heat, energy, mass balance, while considering the physical rules. And then we convert it to a form convenient for analysis, represented by a lumped parameter model. Right? This is how we model the process. We linearize the model using linearization techniques, convert the model to Laplace domain. This is a new concept. No worries, we will introduce the concept to you later. This is to a frequency domain. And generate the model transfer functions. This is to switch from time domain to the Laplace frequency domain. We will be able to use computer-based tools, especially MATLAB and Simulink, to solve for process dynamic behavior to standard inputs. We shall be able to understand and classify the dynamic behavior of more complex processes based on their time domain and the transfer function representatives in the frequency domain. We should also be able to develop the empirical models. So we can model the dynamics of simple process systems using response testing and regression methods. Lastly, we will understand the basic control modes, which lay the foundation for the part 2. So here is the lecture schedule for part 1. This is tentative schedule. We can adjust our timetable correspondingly. So we start, because of this Monday is a public holiday, so we start from Thursday. This is a course general introduction. We will continue to give you a brief introduction to process dynamics control. And from next week, we continue to introduce the introduction and start to look at the first principle models for that week. And then we start to introduce the transfer function through Laplace transform in the 3rd week. And then from week 4, we have the first order process, integrating process introduced. This is like the modeling process, and start to learn MATLAB and Simulink. This will be the kickoff of our project 1 as well. So note here, for each week, we correspond the lecture contents to the chapters in the book as well. So you can also review the book content to get better understanding. Then from 5th week, we look at more complex systems and practice with MATLAB Simulink. 6th week, we start to build empirical models and have a look at feedback controllers. Then after recess week, we study feedback controllers in detail. And project 1 is due in October. We may adjust the schedule based on specific needs, but this is overall time plan for this part. Okay, now if you have the book open, you can also get this PDF copy or your hard copy book to have a look at it, because we want to introduce you different chapters, how it introduces different concepts through this part 1. We start from the very fundamental balance equations, introduction to process dynamics and control, and then we move to chapter 2 to develop the theoretical models of chemical process. Especially here, we will review the linearization techniques to simplify the models. Then in chapter 3, it introduces new concept for Laplace transform, and furthermore in chapter 4, we start to look at the transfer function models to link the time domain and the Laplace frequency domain. So this will be the several chapters we will look at. Let's just have this mid-term plan to look at these chapters holistically. Okay, so this is a very quick course overview. Let's finish this video here, and we will continue in next video to the introduction part. Thank you, everyone.